Okay, so this is the second video on inequalities. In the last video, we introduced what they were and what it is that you can and cannot do with them. This one, I'm going to focus on just some examples of how to solve simple inequalities and then how to express those solutions using a number line. So with that said, let's get started. As I said, these two learning objectives we did last time. These are the two learning objectives that we're going to take a look at this time. So here's our first example, example number 1. In this example, we're going to say that 4x is less than or equal to 8. Okay, it's a very straightforward, very simple inequality. My focus really here is going to be less on the solving and more on the expressing your solution. So to get x by itself, that's what we mean by solve, right? Get x by itself. The only thing I have to get rid of this times 4. The way we undo times is we divide. So that would be my really only step that's needed, is to divide both sides by 4. 8 divided by 4 is equal to 2. On this side, 4 divided by 4, they cancel. It leaves me with just the x. I need to ask myself, does the inequality sign need to change or not? In this case, I am dividing, but I'm dividing by a positive. So the sign does not need to change. And this becomes my answer. X is allowed to be any number that's less than or equal to 2. Now that's the answer expressed as an inequality. We can also express the answer as a graph. And so if I was to graph this, some people like to show 0 on their graph. That's not 100% necessary. The number that we care about is the number 2. Okay? So thing with graphing, when you graph something, any part that's colored in, shaded in, drawn over top of, that represents the things that work in your equation, or the things that work, in this case, in an inequality. So this is telling me that x can be less than 2. It's also telling me that x can be equal to 2. So that means at 2, I need to shade in or fill in. I'm going to put a dot at 2, because 2 is something that works. But 2 is not the only thing that works. Anything less than 2 will also work. So if I think about numbers that are smaller than 2, well, 1 is smaller than 2, 0, -1, all these numbers are smaller than 2. Anything to the right would be bigger. So what I need to do is I need to show that my graph covers over everything to the right. Some people like to use colored pencils or markers so that they can do a different color. What I do is I just draw in a graph that goes right above my number line, is what I do. But both of those techniques would work. That's my solution, okay? Now, to verify this, I can plug in 2 to my equation. I'd have 4 times 2, that's equal to 8. Is 8 less than or equal to 8? Yes, it is, so that works. But I also should be able to plug in any number over here. So if I plug in 0, 4 times 0 is 0. Is 0 less than or equal to 8? Yeah, it's less than, okay? Don't forget, the fact that I've shaded all of this means I could also plug in all of the fractions, all of the decimals, all of the negative numbers. There's an infinite number of numbers that I could plug into this that would work. And that's why we draw an arrow to represent the infinite number of numbers that could possibly work. So that's a very basic, very simple example of how to solve, and then how to express your solution with a graph. And those are the 2 skills that you'll need to use as we're working through these types of problems. Here's a second example, one that's a little bit more involved. -5x plus 10 is greater than 25. Okay, -5x plus 10 is greater than 25. Now, solving this is just like an equation. If this was an equal sign, I want to get x by itself. I start with the thing that's furthest away from x and I work my way in. The only difference is with inequalities, we've got that little rule that we have to be careful when we multiply or divide by negatives, but the basic process is the same. I start with a 10. What cancels out a positive 10? Negative 10s do. Or another way to think of it, what cancels out adding 10? Subtracting 10 does. So I'm going to subtract 10 from both sides. These will cancel. That leaves me with a -5x. 25 minus 10 is equal to 15. Does my arrow need to flip? Well, I'm subtracting, I'm not multiplying or dividing, so no, my arrow is not going to flip. Now on this step, I've got a -5 times x. What cancels out times? Division does that. So I'm going to divide both sides by negative 5. When I divide both sides by negative 5, these will cancel. That leaves me with an x. 15 divided by negative 5 is negative 3. Does my arrow need to flip? Well, in this case, I am dividing, and the number I'm dividing by is negative. So that is the rule when I need to flip, dividing by a negative or multiplying by a negative. So my arrow does flip. This is my answer written as an inequality. If I want to graph that, I need to find the number negative 3 on my graph. Does negative 3 work? Well, this says x has to be less than negative 3. So is negative 3 a number that works? It's actually not a number that works. So the way I represent that negative 3 is the boundary, but it itself does not work, is instead of putting a dot, I'm going to put a circle. And now x can be anything that's smaller than that. Smaller numbers go to the left. So I'm going to shade or draw an arrow that goes to the left. And so that's the way I would express my answer with a graph. I use an open circle because negative 3 does not work, but it shows that that's where my shading or my arrow is stopping. It's stopping at negative 3. All right, let's do one more problem that's a little bit more involved. Actually, I'm sorry, we're going to do 2 more problems. My mistake. We're going to do 2 more problems. Example number 3 is an example where like we saw with equations, I potentially could solve the problem 2 different ways. There we go. I'm sorry, negative 10. There we go. I'm struggling with this example. I apologize for that. But there we go. 2 times the quantity x plus 3 is greater than or equal to negative 10. Okay? So this is a problem where we can solve it 2 different ways. Just like we did with equations. Method number 1 was to simplify first and then solve. So if you choose method number 1, simplify first and then solve, you would distribute this 2. So I'd have a 2 times x, and then a 2 times 3. And now my equation is simplified, so then I would solve. Subtract 6 from both sides. I don't need to flip the arrow because I'm not multiplying or dividing. Negative 10 minus 6 is negative 16. Now I'm going to divide both sides to cancel out this 2. So I need to ask myself the question, do I need to flip the arrow? Well, I am dividing, and there is a negative sign here, but the number that I'm dividing by is positive 2. That's the number I'm dividing by. So since the number I'm dividing by is positive, I do not need to flip the arrow. X is greater than negative 16 divided by 2 is negative 8. So that would be my answer if I did the simplify then solve method. Notice that I could also do the just solve method. If I wanted to get rid of a multiplying by 2, I could just jump right into let's divide both sides by 2. That'll cancel this out. X plus 3 is left. Negative 10 divided by 2 is negative 5. Now I'm going to subtract 3 from both sides. I don't need to flip the arrow. Negative 5, take 3 away, leaves me with negative 8. So I get the same answer both ways. It's actually pretty similar to the same amount of work. I'm just working with slightly different numbers. Okay, so 2 different methods. Like I said in the other video on equations, probably at this point in your math career, most of us prefer this method. And that's okay. Simplify it first, then solve, and you're good. I just want us to remember that there is this other method, and there will be times where that method is useful. But whichever way you do it, let's finish by looking at the graph. So on my graph, I need to find negative 8. Okay? Now, negative 8 represents my boundary. So I'm either going to put a dot there or I'm going to put an open circle, one or the other. How do I know which? Well, the fact that this is greater than or equal, the equal tells me that negative 8 works. So I am going to put a dot to show that it works. And now this is telling me that x is bigger. Remember, Pac-Man eats the big ghost. It's bigger than negative 8. So any number bigger than negative 8 works. Well, big numbers, sorry about that, go this way. This is the way big numbers go. So negative 7, negative 6, 0, 5, 10, 100. Those numbers are all going in this direction. And so that's what my graph would look like. Like I said, some people like to show where 0 is. So if you want to put a 0 on your graph, that's fine. It's not a problem. It's not required. So there's example number 3. All right, finish it up with our last example, example number 4. In example number 4, we're going to have a 1/2 x plus 5 is less than or equal to 10. 1/2 x plus 5 is less than or equal to 10. Okay, so I'm going to start working my way into the x. And the first thing I want to do is get rid of the 5 because that's furthest away. I'm going to do that by subtracting. 1/2 x less than or equal, I don't need to flip the arrow because I didn't multiply or divide. 10 minus 5 is equal to 5. Now I need to get rid of this. And this is the first time in our class we've talked about a fraction. And so you probably remember from a previous algebra class or previous math class, but there's 2 ways that you can think of this. And I'm going to take a look at both. They are exactly the same amount of work. They are exactly equivalent in every way. It's just 2 different ways of thinking about this. And so I know that there will be some students who think about it one way, some students who think about it the other. They're both fine, so I'm going to show both. You just do whichever one you like. Some people think of this as 1/2 times x. And if you think of it that way, then the thing that cancels out a times is a divide. 1/2 times x I can cancel out by doing a divide by 1/2. So these 1/2 will cancel. That leaves me with an x less than or equal. Now here's the part where the people who do it this particular way have to be very, very careful. This is not x divided in half. I'm sorry, this is not 5 divided in half. It's 5 divided by a half, okay, which are 2 different things. Try this on your calculator if you're not sure, if you don't believe me, or we can talk. If you shoot me an email, we can talk offline and I can explain more fully why it's happening this way. But it turns out when you divide something by numbers that are small like this, fractions less than 1, your answer actually ends up bigger than what you started with. So 5 divided by a half is actually equal to 10. Okay, so this is one way that people think about it. But those who struggle a little bit with fractions, they tend to not like this method. And that's okay, because we've got a second method that's mathematically equivalent. It's just a different way to think of it. So 1/2 times x, some people remember that they learned back in middle school or elementary school that multiplying by a half is the same as dividing by 2. And so some people, they look at this fraction and they think of it this way. I'm not multiplying by a half, I'm dividing it by 2. That's what I'm actually doing. And so now the question becomes, what cancels out a divide? Well, canceling out a divide would be a multiply. So if I multiply both sides by 2, multiplies and divides cancel. That leaves me with an x. And then on this side, I get 5 times 2. That's equal to 10. Notice both of them give me the exact same answer. And they're the exact same amount of work. It's just 2 different ways to think of it. And so it's totally 100% up to you which way you want to do it. It doesn't matter to me. I will tell you, me personally, I tend to do it this way because when I was a student way back when, I never liked fractions very much. So this tends to be the way that I do it. But you can do it any way you want. All right, let's finish up this video with a quick graph. I need to graph x is less than or equal to 10. So that means I need to find 10 on my number line. X is allowed to equal 10. So I need to put a dot at that spot. And now x are all the things that are smaller than 10. So smaller things, they go this way. And so that's the way that I would shade. All right, so there we go. There's 4 examples of solving inequalities that are basic, simple sort of inequalities. Hopefully that helped you. Thanks for watching.